Good day, Mom Kim and classmates. So for today, I'm gonna discuss about the introduction to logic. So logic. Logic is a systematic study of valid rule of inference, the relations that lead to the acceptance of one proposition or the conclusion on the basis of a set of the other proposition or the premises. Propositions. Propositions are a collection of declarative statements that is either a truth value, true or logic 1, or a truth value, false or logic 0. Denoted by a propositional values P, Q, R, S, etc. and connectives like or, and, not, etc. So truth table. Truth table is a mathematical table used in logic which sets out the functional values of logical expressions on each combination of values taken by their logical variables. Note: to construct a truth table, the possible combination depends on the number of statements. For the formula, 2 to the power of n, where n is the number of propositions involved. So for example, we have two numbers of propositions. So 2 to the power of 2 is 2 times 2 is equals to 4. So your truth table should have four propositions or the truth table. And another example is there are 3 numbers of propositions. So 2 to the power of 3 is 2 times 2 is equals to 4. 4 times 2 is equals to 8. So it should have 8 propositions of the truth table. So for the logical connectives, there are 5 symbols of a logical connective. So first is that arrow or that symbol that looks like letter V, which is the or the disjunction. And the opposite or the upward of letter V is called and or the conjunction. For not a negation is look like a curve or like a straight then down. For that arrow that goes to the right arrow, it is called the implies or the conditional or if then statements. And that arrow that has both arrows it is called the if and only if or the biconditional. At this juncture, let us discuss one by one all the logical connectives. So first off, we'll discuss about or the disjunction. So or is 2 propositions P or Q is true if at least any of the propositional value P or Q is true. So for the truth value is for P we will start always TTFF, then Q is TFTF because we'll just divide it. We'll divide P 2 into 2 halves. So we'll just TFTF. And the P or Q is, it says here that 2 at least any. So if you can know that one or the truth table have at least one true, then it is true. So TT true. TF, so at least one, so T. Then FT is T. Then FF, so it doesn't have true, so it means that is false. Next, logical connectives is and or the conjunction. It is 2 propositions P and Q is true. So 2 propositions are both true. If both of the propositional value P and Q is true, so it's true. So truth value TTFF again. then TF, TF, then P and Q. So it says again, and is both true. So TT, true. TF is F because it says both true. Then FT is false, then FF is false. Is the not or the negation. It is the negation of a proposition P as false when P is true and true when P is false. So it is just the opposite of the first variable or the P itself. So if P is true, then the not P is the opposite. So it is the false. So let's have the truth table. TF. So what is the opposite of T? It is false. So not P is false. Then F. What is the opposite of F? So it is true. So let's go to the next logical connective. So the next is implies conditional statements. An implication P, right arrow Q is the preposition is, or it is read as if P then Q. It is false if P is true and Q is false. The rest cases are true. So for the truth table, P, T, T, F, F, Q, T, F, T, F. So P, if P, then Q. So it says here, it is false if P is true. False if P is true and Q is false. So TT is true. TF is false because it says here it is false if P is true and Q is false. So at this stage is P is true and false is Q. So it means that it is false. Then FT is true, FF is true. Last but not the least is the if and only if, or the biconditional. If and only if is a biconditional logical connective which is true when P and Q are the same, or whether it is false, or both true. So those are true. So let's take a look at the truth table. So P, T, T, F, F, Q, T, F, T, F. Then P biconditional Q. So T, T is true because it is both the same. TF is false because it says that the rule should be the same in order to make the truth table true. Then FT, it is false because it isn't both the same. Then FF, both are the same, so it is true. In logic, there are clues in order to make your solving or your analyzation more easier. So for this is for the truth table, guys. So logic connectives or the disjunction, you'll just look if FF or the truth table is FF, then it is false. For and conjunction, TT, it is true, or the truth table of P and Q is true, then it is already true, and the rest is or false or are false. Then not or the negation, it is just the opposite of the first or the P. It is just the opposite of P, Q, R, yeah. Then implies or the conditional statements, you will just look at the truth table if it forms like TF. If it is TF, it is already false and the rest are true. Then if and only if or the biconditional, it is just easy, guys, because both are the same, whether it is true or false. Here are the answers, guys. So first symbol is not P. So since that means that it is the negation or not, so you'll just make it the P, the given proposition of P into not or negate. So in here, I love math. So the negation is I don't love math. Or it is not the case that I love math. The next is P or Q. So P is I love math and Q is I love science. So or the sign that is going or looks like letter V, you just add the word or. So I love math or I love science. So next symbol, P and Q. So you'll just add and in the middle of P and Q. So I love math and I love science. The next symbol, P if then R. So since if then, so you will just put in your mind that if should always go first, then will go next. So if P is I love math, then R is I am an engineer. So then I am an engineer. So if I love math, then I am an engineer. So next symbol, not P and Q. So in here, guys, since P and Q is in the first parenthesis, so you'll just focus first P and Q. So P is I love math. So you'll write I love math. Then and the symbol and. So and is you'll just write the and. Then Q is I love science. So I love science. So I love math and I love science. So since we have the negation or not, you'll add it is not the case that I love math and I love science. So that is the answer. The next symbol, not P, if then, not R. So we have here the if then. So first you'll just substitute first the not P and not R. So not P is negate, so I don't love math. Then next is you'll substitute the not R. So R is I am an engineer. So you'll negate it, so I am not an engineer. Then you will add the if then. So if in the first sentence and then in the next sentence. So if I don't love math, then I am not an engineer. So next examples. Example, P and Q if then R. So substitute first P, Q and R. So P is I love math. Q is I love science. So since we have the connective and, so you just substitute and. So I love math and I love science. Then you'll substitute R. So R is I am an engineer. So you substitute I am an engineer. Then you look at if then. So if in the first sentence and then is in the next sentence. So if I love math and I love science, then I am an engineer. So last example of the symbol is not P and not Q if then not R. So first thing you'll do is you'll substitute not P, not Q, not R. So negate all our negations. So you will negate all the proposition given. So I love math, so I don't love math for not P. And because of the connective and. The not Q is I love science. So I don't love science. So I don't love math and I don't love science. Then you'll negate R. So R is I am an engineer. So you'll negate it so it will become to I am not an engineer. The next thing you'll do is to substitute the if then symbol or if then connective. So if in the first sentence, then will go to the next sentence. So if I don't love math and I don't love science, then I am not an engineer. So it is always easy, guys. So always remember to just substitute and always think the or analyze both symbols given and the propositions given.